We'll practice using the work-energy theorem to analyze work done by forces. Here's the problem. A constant 20 Newton horizontal force pushes a 4.0 kilogram box 6.0 meters across a rough floor, and the box moves at constant velocity. Part A, find the work done by the applied force. Part B, using the work-energy theorem, explain why the change in kinetic energy is zero and find the work done by friction. First, find the work done by the applied force. Work is force times displacement in the direction of the force. W applied equals F times D equals 20 times 6.0 equals 120 joules. Now apply the work-energy theorem. Net work equals change in kinetic energy. Since the box moves at constant velocity, its change in velocity is zero, so change in kinetic energy is zero, and therefore net work is zero. The net work is the sum of work by applied force and work by friction. Set that sum to zero and solve for work by friction. Net work equals W applied plus W friction equals zero. So W friction equals negative 120 joules. Remember, when an object moves at constant velocity, the net work is zero, so the work done by the applied force is exactly opposite the work done by friction.